with our first presenter who really needs little introduction. That's Todd Zabel. Todd is the author of Built to Fail: Why Construction Projects Take So Long, Cost Too Much, and How to Fix It. He's also the founder and president of Strategic Project Solutions and the founder of the Project Production Institute. Todd's a pioneer in the application of operations science and capital projects, and we're really honored to have him share insights on production engineering, production modeling, and control versus the current approach. So with that, Todd, I'm going to hand it off to you.
Thanks, Gary. Uh, Obviously, looking forward to an excellent day with lots of participation from many places, both on the academic side and industry side from around the world. Ed McCann and I have been working on a paper that brings together many of the things that we've been working on at PPI for many years and beyond that, going back 30 years ago, believe it or not. And this idea is how to put together an integrated approach to managing production systems and primarily the optimization. So really the founding of this thing and what keeps us motivated and somewhat bewildered is that project performance, continues to be poor and does not seem to be getting any better. However, as you mentioned, we have a significant uptick in the amount of work that's coming down the pike, if you will. But there's still a lot of carnage out there that we don't need to get too far into that. But I think it's still not anywhere near where it needs to be, and perhaps it's not getting better; it's getting worse. The reality situation, as we've said over and over, and this is somewhat setting the stage, is that the current approach really overemphasizes this idea of administration. We see projects as administrative events, and we underinvest in managing production, or what we might call the work. It's gotten to the point where we believe that in some instances, the people that are running projects, and no offense to anybody, but this is truly what we're seeing, don't understand how to manage the work, and I'll talk about that later in the presentation. The bottom line is we need a more effective approach, and we need to apply what we have in the way of science and modern technology. We've been pounding this pretty hard through the years, but we really need to ask ourselves, why do we expect that thinking methods and tools developed at the turn of the last century and the middle last century are going to solve problems? They really never have. And again, we don't need to get into productivity factors and curves and all that stuff that have happened through the years, but it's never really worked. And if somebody wants to challenge us on that, I'm happy to have that discussion. But more importantly and more interesting is we continue to try to keep making it work. All right. And so when we talk about what is it that we're trying to make work, and this is an important graphic, we're going to come back to this later. We believe, and we go to great extents to take what is a business need, if you will, and through the business objectives, whether they're environment, health, and safety, milestones, related scope and dates, budget, et cetera. And we try to create a plan, and that plan really focuses on what work needs to be done by who and when. And out of that, we produce work breakdown structures, work packages, bar charts depicting activities and durations, production rates, rules of credit, and all sorts of things that we can use to monitor the cost and schedule related to the work. All right. We report progress back up to see where we are on plan, and then we report progress back up towards the business objectives, if you will, using percent complete accounting. I mean, it's actually crazy when you think about the idea of percent complete accounting. If we have $10 to spend, we spent, and if we spent 8, we're 80% complete. It just doesn't really make sense, but that's what we do. And a lot of people never even heard of the percent complete accounting. We use cost performance index and schedule performance index and the rest. And what we do is we try to figure out how are we doing compared to the plan that we created, that in some instances may not even have input from those that are doing the work. Now, one thing we have accomplished through the years, and Lean Construction Institute's really been at the forefront of this through Last Planner and the other stuff, is this idea of input from those responsible for the work, aka the last planners. But I think we need to ask, do the last planners actually know what they're doing when it comes to managing work? Managing work is a whole knowledge set in itself. You learn that in the operations research and industrial engineering schools that focus on that. We're going to talk a little bit about some of those ideas and concepts later. Again, despite the poor performance, we continue to make the same approach succeed. We try to do things like move work offsite and industrialize it. We're seeing some of the most incredible things. We were introduced to a term a few years back by Mark Reynolds. I don't know if he created the word, but he used the word, and that was builders in sheds. And the idea was we're going to do the same thing. We're going to do it in sheds. We have now morphed that into a new word that we might call buyers in shed. We're seeing contractors who move work off site, but they don't do any of the work. They still use subcontractors. And when you begin to look at that from a production perspective, you can see that there are several unintended consequences that come with that. We're trying to find better means of scheduling, whether it's through advanced work packaging, TACT, pool planning, AI-based systems, and the rest. The pursuit of the crystal ball and being able to predict what's going to happen through creating schedules is an interesting thing to observe. People are looking to use visualization so they can better see how things fit together. Probably the most interesting thing to many owners is the automated capture of progress. So there's investment in drones, photogrammetry, dogs, etc. And the question might be, what else is being attempted? So we continue to make the same framework operational, but it's not really working the way it should. Okay, and why is that? One, it ignores the fact that projects are production systems should be managed as such. So we're missing the production element of this. All right, we've somehow gotten away from the idea that we're in business to design, make, deliver, install, and commission things. When we do talk with people about production, they don't really understand it because there's a lack of a fundamental understanding of project and production dynamics, right? That's going on in there. And there's an insufficient framework or know-how and the technologies to effectively and efficiently manage work, right? So we don't really understand that we're dealing with production. We don't understand how production and projects are related, and we don't understand the latest tools that are out there because we're not really that interested in production. All right. So I'm going to propose a few things here and then get down to what I believe is probably the most important part of this is what should we go do? What do we propose in that is different and the purpose of this paper? So one, projects are production systems, right? Production engineering, which I believe the next session Roberto and Lon are going to talk about, can be used to improve production. Production modeling can be used to design and optimize the actual production systems, and production control can be used to ensure the production systems behave as designed. All right. To some, these may be new concepts, but they've been in practice in other industries for a long time. And the work that PPI has been doing is to bring this over to the delivery of capital projects or construction, and to provide the means for people to take advantage of what others have and are using in other industries. Okay. A quick reminder, we're not going to spend much time on this, but it's important to understand that PPI defines and bifurcates a schedule from a production system. A schedule is what we want to have happen. A production system is basically all the entities that are going to create what we want to have happen or make what we want to have happen, and therefore is the production side of things. So we simply say there's the demand that's created by a schedule. It tells us what should or what we want to have happen. There's the production system that all these entities together will deliver towards that schedule, all right, or make that schedule reality. If you had a boxing match or a cage fight between the schedule and the production system will always win because it is reality. It is what's really happening, all right? This is a great example here. Moving quickly here on the left, we can see the demand profile for, I believe these are pipe spools. And this was what the schedule says needs to be done. All right. Total number of items flowing through the system on the left over time. And if we look at what the production system said, okay, when that actually it was going to take longer because the resources that the schedule desired to have available were not available the way the production system was configured. And therefore, the project or this scope of work rather for the project was going to be 6 months later than desired, or 5.5 months. This is very, very common when you compare the schedule of what we want to have happen with what the production system can deliver. PPI also proposes, and again, this is just a review, that the cost, time, and cash related to the delivery of projects or even a production system is related to how you design the product, how you design the work processes to create, make, or build that product, how you allocate or invest capacity contributors such as labor, equipment, and space, how you manage or control inventory, including inbound stuff. Most importantly, work in process, not progress, which is anything underway, and finally finished work or finished goods, and then the relationship between variability and how it impacts the use of capacity and inventory. Basically, the more the variability, either you're going to have loss of capacity, build up inventory, or some combination of both. The reason why we really want to have an effective crystal ball to predict what might happen on your project, then you need to measure the WIP over time, not try to predict what the schedule might do. Okay. So again, this is a little bit of a review on two concepts, but taking the last concept, and that is the relationship between capacity, inventory, and variability. There's very specific mathematical equations and resulting curves that can be drawn. I'm not going to get into this. Many of you have seen this before. This is all available on the PPI website, and I'd encourage you to take a look. But just a quick review here: the more work in process you have, the longer it's going to take. The less, if you have too much work in process, you're going to get to the point where nothing's going to happen other than time's going to get extended. And the same is true if you have too little work in process. So you don't want to be too lean, or as Mark Spearman would say, anorexic, but you also don't want to be bloated. So too lean or too bloated, and time is going to go out. If you drive the utilization of the capacity as high as you can, and you're seeking to get more out of workers without changing the system perspective of the process, then like the freeway or the motorway, it's going to take longer to get the work done. All right. And so on and so forth. So I would encourage you to take a look at this. But using all that, the 5 levers and the operation science, if you will, the relationships of those mathematical equations that dictate what's going to happen, we can apply various methods and tools to the design of work for the delivery of projects, or we can call them the production systems for the project. All right. The basic idea here is we could use production engineering to determine how the work needs to be done and what is needed to do the work. All right. And so this is mostly done through process and information flow diagrams. It says for this particular product, we need to execute these specific operations or steps, and we need to have these types of tooling, equipment, labor, skills, etc. So it's very clear on how we do the work and what is needed to do the work. Now, that is a different study, if you will, than what production modeling does, which is how to most efficiently and effectively use the resources to do the work. And so let me give you an example. Should we have one big excavator or 2 small excavators? Should we do the work on-site or off-site? If we do the work off-site, is it better if we outsource it and buy it, or is it better if we insource it and make it? If we make it, how much do we need to have in work in process through that production system versus if we buy it, how much do we need to have in inbound inventory, right? That we can then put together as part of, let's say, maybe a subassembly to make an assembly. So production modeling takes the work of production engineering and begins to ask the question, how do we use the resources that are needed based on the production engineering to do the work? All right. And then finally, all production systems, if not controlled, will begin to behave in any way that they feel they need to behave. So we need a way to ensure the production system behaves in accordance with the design and the policies, right? The production engineering portion is a big chunk of the design. The policies related to one excavator or two, how many hours we may work a day, what we might have in the way of work in process at any given time, what our goals are or policies, if you will, around capacity utilization, those things that come out of production modeling. We want to take all that and make sure that we're controlling to that. And production control is another area that we could spend a whole bunch of time in, and we do in some of the courses that we offer with Texas A&M and Stanford, amongst others. So I think what we're talking about here, and really the purpose of this paper, is to ask the question, how does all this come together? Because now we have all this, and we've been working at this for a while, but how does it fit together? All right. And so what the paper proposes is that we take this approach, all right, of attempting to plan and schedule work and using monitoring of cost and schedule reporting back through various means, and to bring a different view to this, if you will, especially with an emphasis on the center part, and to actually do production engineering of how the work occurs, and to do production modeling of what resources and what combination are the appropriate amount to be as effective and efficient as the production system could be. All right. And so this is really the gist of what we're talking about here, is a different way of looking at projects as a production system rather than as an administrative process, to actually design and optimize the production system by first taking and engineering the production system. Clearly, we would like to get the production engineering and even the production modeling done early in the project. On the SPS side, we actually have customers now that have come to the realization that design and optimization of the production system can happen prior to the design of the product or the facility. I want to repeat that. We have customers now that have come to the realization that production systems can be designed and optimized prior to the design of the product, or in the case of construction of facility. How can that be? Well, if you think about it, the production systems, whether they're structural steel, piping, electrical, we could say that they're any type of permanent equipment or material that goes into a facility or an asset. Those production systems, for the most part, are operating. They're called companies. They might be engineering companies. They might be architectural companies. They might be specialty contractors. They might be original equipment manufacturers. Those companies are out there operating today. What owners and construction management firms are doing are they're plugging and playing those production systems to create an overall project production system that will deliver based on some identified and defined need of a customer, most often an owner. All right. So what we're able to do is take those production systems, understand how they operate, and as they come together, use production engineering and production modeling to optimize, because we already know there's probably going to be site grading and preparation and earthworks. We know there's got to be some kind of foundation. We know there's going to be a structure, could be concrete or steel. We know there's going to be some kind of mechanical, electrical, piping type stuff going on. It may not be a building, so there may not be cladding or vertical conveyance or a roof, but the majority of this stuff we know is going to happen. We know a lot of times within some parametric amount how much of it needs to happen, and we're able to create these models in advance. And so for those that have made the shift from this more conventional approach developed back in the last century, the beginning and middle last century, to where we are looking now at taking a production view, the question then becomes, why are we not doing this earlier? All right. And so I'm going to go ahead and stop there, Gary, and that's the end of the presentation, if you will.
All right. Very good. So if you got a question, again, please drop it in the chat or the Q&A function there so that you can interact with Todd. Maybe while we're seeing if we got a question from the audience, Todd, let me throw one at you. How would you use what you proposed here, production engineering, to evaluate alternative development ideas for any given project?
Yeah, that's an interesting scenario. There's really two areas there, and probably even the production modeling might be more interesting. But the roots of the production modeling and the production engineering come out of the design of the facilities themselves, right? I always talk about this great argument that Mark Spearman had when he said operation science doesn't apply to projects. And so where the real deep operation science stuff that we're now, or I should say we have for the last 2 decades, work towards applying to projects or construction is rooted in manufacturing, right? So if you have a processing plant or a manufacturing plant, or you're trying to figure out how best to design an asset, whatever it may be. I mean, we've been involved in looking at a flow through hospitals, right? The list goes on and on, field development for oil and gas, or even solar farms, whatever the case may be. This idea that the modeling can be used to understand how best to design. It's part of the design of the asset, but at the same time can be used to optimize the delivery of the asset and then come together to provide both, if you will. So probably the best way to understand is a model or a digital twin of what's to be built, and a modular digital twin of how to build what's to be built, right?
Makes sense. So how would it mesh up with stage? A lot of people use stage gate approach on the current approach. How would this mesh up or not mesh up, or throw out stage gate completely?
Well, that's a question for you. So if a turbine takes 5 to 7 years, I don't really know how you use those stage gates anymore. I don't know if construction today has time for stage gates anymore, at least on where the big money's being spent. We're not seeing a lot of stage gate stuff. And with the lead times becoming as long as they are, and the criticality of time to market, I think stage gates is, again, it's one of those things that a lot of people are trying to make work. I don't know if there's time for that anymore. I mean, there's got to be something, obviously, that gets corporations through their governance to ensure that they're making a coherent investment. But the actual gate process, I think its days are numbered.
Yeah, I would agree.